Number 5, list the first 5 terms of the sequence a sub n is equal to 3n factorial over n minus 1 factorial. If it doesn't specifically tell you where to start with n, you can assume that you'll start with n equals 1, then 2, then 3, then 4, then 5. So to get the first term, what we are going to do is just plug in n equals 1, so this will be 3 times 1 factorial over 1 minus 1 factorial. Okay, so 1 factorial is just 1. And if you plug in, we end up getting 0 factorial, but I did tell you that 0 factorial is also equal to 1, so the first term is equal to 3, right? The second term, we will go ahead and plug in 2, so I'll have 3 times 2 factorial over 2 minus 1 factorial. 2 factorial is 2 because 2 times 1 is 2, times 3 is 6, and then 2 minus 1 is 1, 1 factorial is 1, so we'll get 6 as our second term. And then our third term, we'll plug in 3. We'll get 3 times 3 factorial over 3 minus 1 factorial. Okay, 3 factorial is 3 times 2 times 1, which is 6, times 3, which is 18, over 2 factorial, which is 2 times 1, which is 2. So our next term will be 9. And then a sub 4 is equal to 3 times 4 factorial over 4 minus 1 factorial. So 4 factorial is 4 times 3 times 2 times 1, which is 24, times 3 is 72. And then 4 minus 1 is 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. And if you divide that out, you'll get 12. And then the fifth term, we'll get 3 times 5 factorial over 5 minus 1 factorial. And if we work that out, we'll get 5 factorial, which is 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, times 3 is 60, times 2 is 120. I think this is going to be 360 if I did that correctly. 5 minus 1 is 4 factorial, so 4 times 3 times 2 times 1 is 24. And when you take 360 and divide it by 24, you should get 15 as an answer for that one. So the first 5 terms would be 3, 6, 9, 12, and 15. There would be a faster way to work this if we're used to working with factorials. If you recall, n factorial would just be n times n minus 1 times n minus 2, dot, dot, dot. On the bottom, n minus 1 factorial is n minus 1 times n minus 2 times dot, dot, dot. So we could cancel out all the factorials. We would have just been left with 3n. So each time we could just plug in that n, and we would be all set. All right, number 6. Find the limit of the sequence using the sandwich theorem, right? When we're using the sandwich theorem, we want to find the smallest that this will be, the numerator we're going to talk about, and the largest. So I know that negative 1 to the n is going to toggle back and forth between negative 1 and 1. So it's never going to be smaller than negative 1, and it's never going to be larger than 1. So if I used negative 1, 1 plus negative 1 would be 0. And then if the other term would be 1, 1 plus 1 would be 2. So I know it's going to, the numerator is going to toggle back and forth between 0 and 2. So those are the sequences that I can sandwich them between. So I can sandwich the a sub n in between those two. All right, and then the sandwich theorem, we're going to find the limit. So find the limit as n approaches infinity of 0 over n, and that will equal 0. And then we'll find the limit as n approaches infinity of 2 over n, and once again we'll get 0. Okay, and so we can say since the limit as n approaches infinity of 0 over n and 2 over n are both 0, and since that and 0 over n is less than or equal to 1 plus negative 1 to the n over n is less than or equal to 2 over n, then we may conclude that the limit as n approaches infinity of a sub n must also equal 0. Number 7, explain the difference between a sequence and a series. Although yours can change a little bit, a sequence is a list of terms, and a series is the sum of those terms. And if you can think back to when we did the heart, when we cut the pieces of the heart, the different pieces formed the sequence, but then when I put them all back together, that became the series.